So in this video, I'm going to be going over a problem that I found on the SAT Judicial Practice Test number 4, the College Board posted. And this is the hardest problem that I found in Module 1 of the math section. And I'm pretty sure this will determine the difficulty of the questions that precede it. So it's a pretty important question to get right, but it's also the most challenging conceptually. So I'm going to go over it in this video. So in problem 21, in order to solve it, we have to know these three rules down here. And I assume you guys know these rules from school, but if you don't, I'm going to go over them quickly. And I'll include links in the description with like more, not my videos, but like videos that I found helpful when explaining these concepts. But I'm going to only go briefly over them. So in the first rule, it's basically saying that if you have a root and it has an index, the index is considered n, and inside, let's say the index was 3 here, and you have a base that's like 2, and it's to the power of something inside this root, then it would be, let's say it's like 5. These are just numbers I'm making up to show you an example of this rule. Then it'd be to the base, it would be the base to the power of the exponent and the index over the exponent index. So it would become 5 over 3. It would be 2 to the power of 5 over 3. And that's equal to cube root 2 to the power of 5. And that's basically the first rule. And the second rule kind of goes in hand, on hand with it. These are basically called your exponent rules. I'd suggest you know all of these. Maybe not even just for the SAT, but you're gonna know them. You're gonna need them for like pretty much any math class above Algebra 1. So if you have the second rule is that if you have the same basis and you multiply it to the power of different exponents, but you're multiplying them together, then it's that base to the power of those two exponents. So let's say, for example, it was 2 to the power of 4 being multiplied to 2 to the power of 6. Because the bases are the same, which is 2, they become 2 to the power of 4 plus 6, which is 10. And this way it's kind of easier where you don't have to do two different calculations. You could just do 2 to the power of 10. And you're simplifying it. And in the third rule, it's something similar as well. But this time, if you have a base to the power of an exponent in parentheses to the power of another exponent over the whole thing, like on the whole thing, then it becomes that base to the power of those two exponents multiplied. So if you had 2 to the power of 3 all to the power of 4, then it would become 2 to the power of 3 times 4, which is 12. And those are 3 rules that you have to know for pretty much anything. And going back to the problem itself, the problem is basically telling us that this expression right here can be written as ax to the power of b, and it's asking us to find the value of a plus b. So first, what I like to do when I see this expression is I would like to just make it look easier than it currently is. And that's not as hard as this, and it's not that hard to do. So first, you have to realize every singular term. So a single term here would be 6, and 6 is being multiplied to 5 root 3 to the power of 5 x to the power of 45, and that is being multiplied by 8 root 2 to the power of 8 times x. And we can actually simplify this further. So we obviously knew that the 6 was its own term, but there's actually we can split these two roots into 2 more terms. So how you do that is you do 6 times 5 root, because that doesn't go away. But you can split these two, like up here. I'm going to change my color so it makes it easier to see. You can split these two terms right here, like these two right here, because they're just being multiplied in the square root anyway, so you can split them up. So how I would split them up, or how you should split them up, is you do 5 root 3 to the power of 5 times 5 root x to the power of 45 times 8 root to the power of 8 root 2 to the power of 8 times 8 root x. And this is the most simplified way you can get it. But it still wants us to get an ax to the power of b. So how I would do that is you can actually simplify a lot of these using the first rule that we went over. So if it's 5 root 3 to the power of 5, then looking at this, then we would say this becomes 3 5 over to the power of 5 over 5, which is just 1. So it becomes 3 to the power, uh, it would become 3 to the power of 1. And the 6 would still be here. Nothing happens to 6. And then we would do x to the power of 45 divided by 5, which is 9. And then this would become, it would be 8 root 2 to the power of 8. That becomes 2 to the power of 8 over 8, which is 2 to the power of 1. And this just becomes x. So you don't see exponent here, but if you don't see an exponent, that's basically to the power of 1. Like 2 is just equal to 2 to the power of 1. They're basically the same thing. So you would imagine that there's a 1 here. So it becomes x to the power of 1 over 8. And now you can kind of see how it's getting closer to this form right here. So that'll just become 3 times 6. I know I got order there, but 3 times 6 times x to the power of 9 times 2 times x to the power of 1/8, which just becomes 1236 times x to the power of 9 x to the power of 1/8. And using the second rule, we can simplify these two. The second rule says if you have the same base, which we do, they're both x, then you can add these two together. Add the two exponents together. So basically adding 9 and 1/8. Now, since in the digital SAT you can use a calculator for everything, I'll just plug this into your calculator, or you can do it in your head, and it would get you 36 times x to the power. You could have it. I would have it as a fraction, so it'd be 73 over 8. X to the power 73 over 8. And then now it's in the form that I wanted us to have. Ax to the power b. B is 73 over 8. A is 36. And it's telling us to add these together. If you add them together, that would get you, again, use a calculator for this. It would get you 361 over 8. And that is